Hello again, Math Dog here. This video is part 2 of graphing a linear inequality in the XY plane. The XY plane usually represent like this. You got a coordinate grid, and this would be the X direction, this would be the Y direction. This is again part 2. You want to watch part 1 of this video first. This video is not to be shared or reproduced without the written consent of myself, the Math Dog. So let's begin here. So first of all, we'll talk about how to identify a linear equation in two variables. A linear equation has a variable to the power, each variable has a power of 1. So for example, y equals 3x plus 4. We don't usually write this, but you could write y to the first equals 3x to the first plus 4. So each variable, x and y here, are to the power of 1. Again, 2x minus y equals 7. X and y are both to the first power. Linear equations in two variables, x and y for example, graph as straight lines in the xy plane, such as this example here. So contrasting that, so this should be, again, we're talking about how to identify a linear equation in two variables. Now we're looking at nonlinear equations for a moment. So this first example, y equals x squared, which actually I've graphed right here, graphs as a parabola. It's not a straight line. So while y is to the first power, x is not. It's the second power. So this is nonlinear. X minus y cubed equals 4. X is the first power, but y is to the third power. This would not graph as a straight line. And then this problem here, y equals 1 over x, well that is 1 over x the first, but 1 over x, by definition, we write this as x to the negative 1. That's a negative exponent. We'll talk more about that in another video. But 1 over x is actually x to the negative first, so it is not to the first power, it's to the negative first power. So none of these are linear equations or functions. So again, recalling the different types of inequality signs, you have less than. So in a linear inequality, this will graph as a dashed line. Less than or equal to will graph as a solid line. Greater than will graph as a dashed line. Greater than or equal to graphs as a solid line. Talked about that in part 1. Also in part 1, we talked about half planes. A line divides the XY grid into two parts. So you have the line, solid or dashed, and you have what we call two half planes. Here's half plane 1, half plane 2. Finally, in part 1, we summarized how to graph the solution to a linear inequality, so just going through those again here briefly. First, determine if the boundary line is solid or dashed based on the sign. Write the inequality as an equation, replace that inequality sign with an equal sign. Solve the equation for y, putting it in the form y equals mx plus b. Draw the line by first plotting the y-intercept, then construct some points using the slope to guide you to draw the line. The only exception is when you have a vertical line, which will be of the form x equals. Find a test point not on the boundary line. Plug the coordinates into the original inequality. If the test point makes the inequality true, shade the half plane on the side of the test point. So if you have a boundary line, and this is your test point over here, let's just say that's 0, 0. So if you plug it into the original problem and it makes it true, you will shade on the side of the test point. If the test point though makes the inequality false, you will shade on the opposite side. So if this test point made the original inequality false, you'd shade on the opposite side of the test point over here on this half plane. So putting a linear equation into slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope, b is the y-intercept. Sometimes you see this written like in statistics, y equals ax plus b, but m or a are the slope. Now we have another form of a linear equation called standard form, which is, we often write it as ax plus by equals c. So we're going to solve ax plus by equals c for y. In other words, we're going to convert this to slope-intercept form. B cannot be 0. I'll talk about that in a moment. So we have ax plus by equals c. If I'm solving for y, first I will isolate the by, so subtract ax from both sides. So I get by equals negative ax plus c. Now, b cannot be 0 here because that would cause division by 0. That's why I stated this here, but we're going to assume b is not 0. So we get y equals, because b's divide out, y equals negative a over bx plus c over b. Well, this is of the form y equals mx plus b. So actually, if you could put this equation, just look at that equation in this form. If you took negative a divided by b, you would get the value of the slope. If you took c over b, capital C over b, from this equation, you do the division, you would get the y-intercept of the equation in slope-intercept form. So let's put this equation here into slope-intercept form. So 3x plus 2y equals 6. It's in standard form. This is of the form ax plus by equals c. So solving for y, I first subtract 3x from both sides. So then I have 2y equals negative 3x plus 6. Solving for y, I now undo multiplication using division. So I get y equals negative 3 halves x plus 3. So the slope m is negative 3 halves, and the y-intercept b is 3. Now notice what I was talking about. We just a moment ago solved for this. Let's actually copy this. Bring it over to our next page. Okay, so let's, oops, I want to do that. So notice that in this case, again, a is 3, b is 2, and I'm using again this here, c is 6. Notice that negative a, m is supposed to equal negative a over b. In this case, that'd be negative 3 over 2. Notice that's what we got right here. And then b, the y-intercept, is c over b. In this case, that would be 6 over 2, which is 3, which notice we got here. So you could actually take, if you memorize this formula or apply this formula, you could actually just plug the numbers into this stuff and get your slope and y-intercept. However, I just think it's easier just to solve the equation for y rather than trying to memorize something. Okay, so now here's an example. Put the linear equation 4x minus y plus 2x equals 7y minus 8x plus 2 in slope-intercept form. So what I'm going to do first is I'm going to get the y's on one side and the x's and the constants. We have only one constant here too on the other side. So first of all, I'm going to combine like terms on each side. So that's 4x and 2x is 6x. So I have negative y. Let's actually write it this way. So I have 6x minus y equals, I'm going to put the x here first. Switch these. Negative 8x plus 7y plus 2. When you get the x's on the right side, the y's on the left. So I'm gonna put a 1 there for now. So I'm gonna get the y's on the left side. Okay, so I have, when I'm done here, subtracting 7y from both sides, bring down the equal sign. That's 6x. Negative 1y minus 7y is negative 8y. So then these cancel out, that's 0, so I have negative 8x plus 2. So we're having to combine terms first. So here, first thing we want to do is combine like terms on each side. Now we're trying to get the y's on the left side, trying to get the x's and the constants, like the number 2 in this case, that's a constant. It's called a constant because it never changes value. X and y change value because as I change the input x and y, all these expressions with x and y change in value. That's why they're called variable expressions, and this is a constant. So now what I want to do is, again, I want to get the y's by themselves on the left side, so I need to get rid of this 6x. So I'm going to subtract 6x from both sides. Take your time, keep your equal signs lined up. So that's a 0. So bring down to negative 8y. That's negative 8 minus 6 is negative 14x plus 2. Now I'm solving, I want 1y, but I have negative 8y, so to undo the multiplication I use division. So I end up with y equals 14/8. Well, 14/8, because the negative divided by negative is positive, I can divide 2 and everything there. So that's 7/4. So my equation slope-intercept form is going to be y equals 7/4 x. Negative 2 divided by negative 8 is negative 2/8, which is negative 1/4 because you can divide everything in there. So my final equation slope-intercept form is y is 7/4 x minus 1/4. M, the slope, is 7/4. That means a run of 4, rise of 7. And then the y-intercept b is negative 1/4. Alright, stop the video and I want you to put both of these linear equations into slope-intercept form and then restart the video. Okay, let's take a look at these. So letter A, negative 4x plus 6y equals 12. Solving for putting in the form y equals mx plus b. First I need to get the x's onto the right side, so I add 4x to both sides. So I get 6y equals 4x plus 12. Solving for y, undo multiplication by 6, divide by 6. So y is 2/3 x plus 2. That's what you should get for the first one. So the slope is 2/3. So a run of 3, rise of 2, and the y-intercept is 2. Second equation, I would put a 1 there first. So I'm looking for any like terms on each side. Well, there are no like terms, but I'm solving for y. And I want y on the left side because I want y equals mx plus b. So I'm going to subtract 4y here first. So I have 3x plus 10 here because those subtract out. Here I have negative 1x, 2 minus 4 is negative 2, so negative 2y minus 8. I could have done the constants first, and that's what I'm going to do next. I'm going to move the negative 8, I want it on the right side, so I'm going to add 8 to both sides. So now I have negative 1x minus 2y, those are gone, the 8's are gone, and I have 3x plus 18. So now I got to get rid of this negative 1x because I want it to be solved for y, so I now add 1x to both sides. So I have negative 2y equals 3 plus 1 is 4x plus 18. Finally, I want to undo this multiplication using division to solve for y. So I divide everything by negative 2. So y is 4 divided by negative 2 is negative 2x. 18 divided by negative 2 is negative 9. So I get y is negative 2x plus, negative 2x minus 9. The slope is negative 2, or negative 2 over 1. So you go over 1 down 2, and the y-intercept is negative 9. Alright, so now let's actually look at some examples here of graphing these. So this is a dashed line because it's less than. change the original inequality to the boundary equation, which is this. Replace the negative less than sign with equals. Solve for y, so I'm going to subtract 2x from both sides. So I have 3y equals negative 2x minus 6 divided by 3. So I get y equals negative 2/3 x minus 2. So my slope m is negative 2/3. My y-intercept b is negative 2. So first, when we graph, we plot the y-intercept. There's negative 2 right there. Let's do a little better job of that. Okay, my slope is negative 2/3, so I'm going over 3 over 2 down. Let's repeat that to get a couple more points to make it easier to graph. 3 over 2 down. That's a dashed line. Fix that a little bit. I got a mistake there. Do you see it? I only went down 1 here, so that's not right. I got to fix this. That's not correct. So I have to go over 3 down 2, over 3 down 2. So let's try to replot this here. That's looking much better. Alright, so there's my boundary line. So now I need to take a test point. And the easiest test point, when you can use it, is 0, 0. Remember, test points cannot be on the boundary. So my test point is 0, 0. So let's plug that into the original inequality now. So we're going to plug that into this. So we have 2 times 0, x is 0, plus 3 times 0, less than negative 6. Well, 0 less than negative 6 is false. So we shade on the opposite side of the test point here. So we're going to shade below because the test point's above and it's false. So we're shading all this area here on our graph. Actually, again, it goes forever, but we're just going to show it in here. So this is our solution. And it does not include, actually does not include the boundary line. It goes right up to it because it's dashed, but it actually does not include it. All right, let's look at another example. 3x plus 4y greater than or equal to negative 16. Okay, so that's a less than or equal to is solid. Let's write the boundary equation. I have the luxury, I can slide this over. I need a little room here. So I have 3x plus 4y equals negative 16. Solving for y, I need to get the x's to the other side, so I subtract 3x from both sides. Bring down the equal sign, that becomes 0, so I have 4y equals negative 3x minus 16. Solving for y, I need to divide everything by 4. So I get y equals negative 3/4 x minus 4 because 16 divided by 4 is 4 and it's a negative. So my slope m is negative 3/4. My y-intercept b is negative 4. So I start with my y-intercept at negative 4. Technically that's the point with coordinate 0, negative 4. So now I'll create a slope of negative 3/4. So I go over 4 and down 3. And I can get away with doing it again this way. 1, 2, 3, 4, 1, 2, 3. I could go 4 over this way and 3 up and get yet another point, and it's solid. Okay, that's my boundary. Now notice I could use 0, 0 again as a test point. That's what I'll do. And plug it into this. So I have 3 times 0 plus 4 times 0 greater than or equal to negative 16. Well, that's 0 plus 0, so 0 greater than or equal to negative 16 is true. Test point's up in the upper half plane, so I'm shading the upper half plane here. So we're shading, and this time it includes the boundary because it is a solid line greater than or equal to. So there is our solution. Okay, graph the solution to 5x minus 3y less than or equal to 6. Okay, well, that's a less than or equal to, so that is solid. Boundary line. Let's move this over to the left. So we now write the the boundary equation. Replace the less than or equal to sign with an equals. So I need to get the x's on the right side, so I subtract 5x from both sides. So I get negative 3y equals negative 5x plus 6. Solving for y, I divide everything by negative 3. So get y equals negative divided by negative is positive, so that's 5/3 x minus 2. So my slope m is 5/3, and my y-intercept b is negative 2. So first plot your y-intercept at negative 2, then a slope of 5/3 means I go over 3 and up 5. I can do that again. 3 over, 5 up, solid line. Okay, again, this does not go through 0, 0, so I can use that as a test point. Plug it into this, so 5 times 0 minus 3 times 0 less than or equal to 6. That's 0 less than or equal to 6. That is true, so I shade above the upper half plane again. So our solution, there's all these points over here, and of course this goes out like this, goes out like this, but it's this upper half plane is your solution to the problem. Okay, then we have x minus 3y greater than negative 12. Well, that is now a dashed line. Because of the greater than sign. So now let's write our boundary equation, replacing the greater than sign with an equal sign. So we have x minus 3y equals negative 12. I'm going to put a 1 there for x. So now I need to get the negative 3y by itself, so I subtract 1x from both sides. So I have negative 3y equals, now you could write negative 12 minus 1x, but I'm trying to put this in the form y equals mx plus b, so I put the x term first. So negative 1x minus 12, excuse me, divide now by, to solve for y, divide by negative 3. So I get y is negative divided by negative is positive is 1/3 x, and negative divided by negative is positive plus 4. So my y-intercept is 4. My slope is 1/3. So I go over 3 units and up 1. I can do that again. 1, 2, 3, up 1. 1, 2, 3, up 1. So let's put an X there, and we're going to draw a dash line this time. Again, take a test point, and again, once again, we can use 0, 0 as our test point. It's not on the boundary. So going to the original problem, we have 0 minus 3 times 0 greater than negative 12. 0, that's 3 times 0, 0. So 0 greater than negative 12 is true. So this time we shade down because the test point's on the lower half, is in the lower half plane, and it's true. So it's all these points in here make up our solution. Any point here will make the original inequality true. Okay, stop the video. and do this problem. So we have x plus 2y greater than negative 4. I want you to work that out, then start the video and see if what I do agrees with what you did. Okay, so solving this, first thing is greater than, that's a dashed boundary. So now we write our boundary equation replacing greater than with equals. I'm going to put a 1 there, coefficient of 1 for x. Now I'm going to get the x's to the right side, so I subtract 1x from both sides. Bring down the 2y, that cancels. Bring down the equals. So I have negative 1x minus 4. Solving for y, undo multiplication, divide by 2. So get y is negative 1/2 x. Negative 4 divided by 2 is negative 2, so y is negative 1/2 x minus 2, so m is negative 1/2. B, the y-intercept, is negative 2. So my negative 2 is my y-intercept. Slope should be downward, it's negative, so I go over 2, down 1, over 2, down 1, over 2 units, down 1, over 2, down 1. Say dash line. So you would need a piece of graph paper to do this. All these graphing and equality problems, you need a piece of graph paper to do properly. So now again, test point is 0, 0 is not on the line, so I can use that as my test point. Plugging into the original problem, 0 plus 2 times 0 greater than negative 4. That's 0 plus 0 equals 0. That is true, 0 greater than negative 4. So I shade up towards the test point. So it'd be all these points in here, not including the boundary line, and it goes up this way, goes out this way, goes back this way. But because it's dashed, it does not actually include the points on the boundary. Okay, last one here. Stop the video, solve that inequality, graph it. Okay. Alright, let's take a look at this. So I have 2x minus y less than or equal to 3. That is solid because it's less than or equal to for the boundary. So I have 2x minus y equals 3 for the boundary equations. I'm going to put a 1 there in front of the y, coefficient of 1. So I need to get the x's to the other side, so I subtract 2x on both sides. So I have negative 1y is negative 2x plus 3. So now solving for y, I have to undo the multiplication by negative 1 by dividing by negative 1. So I get y equals negative divided by negative is positive, so that's 2x. 3 divided by negative 1 is negative 3. So y is 2x minus 3. So the slope of 2 is the slope of 2 over 1. So m is 2 over 1, and then b is negative 3. So let's start the y-intercept at negative 3. The slope is negative 2, so I go over 1, down 2, over 1, down 2, over 1, down 2. I could go back 1, up 2. It's a solid line. Once again, it doesn't go through 0, 0, so I can use 0, 0 as my test point. Go to the original inequality, 2x minus y less than or equal to 3, 2 times 0 minus 0 less than or equal to 3, 0 less than or equal to 3 is true, so we shade towards the test point. So it's all these points in here, including the boundary because it's solid. And this concludes the video.